Good morning, viewers. I welcome you to our second day, Mathematics Grade 10, Day 2, online teaching. For today, we want to learn about surface area of a frustum. As you all know, that frustum comes from two different types. We have a frustum one in a conical shape and another one in a pyramid shape. So, I will be taking you through a frustum of a conical shape. I will take you through a frustum of a conical shape, and here with me is a sample of a frustum. I hope you can see my frustum here in the form of a trough or a pail that we use back at home when fetching water. So this, we have the bottom part and the upper part you can see. So this one is one of the kind of a frustum in a conical shape. As from yesterday's lesson, you learned how to calculate the surface area of a cone. And you found that to calculate the surface area of a cone, you are using pi r squared plus 2 pi rl. Where some are substituting this 2 pi rl with pi d. The d here was for the diameter. We can substitute it by pi r squared plus pi d l, where the d here was the diameter of the one of the cyclic parts here. You can see we have the upper part and we have the bottom part, which are both in a circular manner. So the diameter here was one of the circles here. L here was the slant height. Then we have got h is the height of that cone. Now for today, we want to see how can we calculate the surface area of a frustum. Surface area. And we say the surface area is what you are able to see, not what you cannot see. So viewers, I hope you can see the upper part and you can see the bottom part plus the curved surface area. Given that on the upper part we have a small r and on the bottom part we have a capital R, what is this telling us? This tells us that either one of the circles here is magnified to give us the bottom part, or the bottom part here was magnified to give us the upper part. That's why we have small r and capital R. Now our frustum here, our conical frustum here is formed from a cone. From a cone. You know the shape of a cone. How do we draw a shape of a cone? Now find somewhere wherever you are, find a place and try to draw a cone. Then from that cone, we see how can we form a frustum. My viewers, wherever you are, find a place, find a piece of paper and a pen and try to draw a cone. Then from that cone, we see how can we form a stump from the cone. Now with me I have a pen. I want to first draw my cone. Then I tell you how did I come up with this frustum of mine. Now initially I had got a cone in this form. In this form. This was my cone. Then from this cone here, I came up with a frustum that you are able to see now. A frustum with both the cyclic part at the bottom and at the bottom and the top with the cyclic parts. Then I have the slant height. My slant height is this one on the cone, the same slant height here. I hope now you have drawn somewhere. And now, how do we come up with our frustum? What we need to do here first is just to cut our cone in a certain part. Now, can you try to cut this part? I hope you are using a pencil. Can you try to grab that part? Then see what is being left. What has been left? If you draw frustum. So a conical frustum is made up from a cone by cutting the upper part, or you can cut the bottom part to cut out a frustum. Now, being that how you are able to see where the frustum is coming from, we want to see how we calculate the surface area of a frustum. How can we calculate the surface area of a frustum? It is very difficult to calculate the surface area of a frustum the way it is if we don't form a cone again. Now, having our frustum, my viewers, try to extend the slant height on the upper part. Okay. Now I ask, try to extend the slant height on the upper part on both sides. Try to extend the slant height on the upper part until it cannot be extended further on both sides. Now after extending this part, I can extend this part. Then check where are the two slant heights meeting. Where are the two slant heights meeting? In that specific diagram, where is that slant height meeting? Where it means, put a dot there. Put a dot there. Put a dot there and tell me what are you able to see? In a comment, tell me what are you able to see? Are you able to see a cone, or are you able to see the same frustum? Learners, in a comment, tell me there what are you able to see? If you are able to see now, okay, have we formed the cone? Have we formed the cone? I hope now it's our cone now. It's our cone. It's a cone. Now you can easily get the surface area of the upper cone and of the whole cone. Because here now we have two cones. We have the larger cone and the smaller cone at the upper part. The cone which was cut to form a frustum. So learners, I hope you are able to see now our cone. Form the upper part and now the bigger cone. Now my question is, how do we find the surface area of a cone? How do we find the surface area of a cone? From our previous lesson yesterday, we learned that surface area of a cone is given by pi r squared plus 2 pi r L. What does pi is the slant height. And what is this our R? R will give the bottom here, which is our capital R here. But do we have the slant height from the point of the where the two slant heights are meeting? The answer is no. What we have is the slant height of the frustum. Now R here to be something like X. So the slant height of the upper cone is assumed to be X. Let's assume that the slant height of the upper cone to be X. Now the total slant height of the larger cone, total slant height of the larger cone, slant height of larger cone is now X plus L centimeters. Now we have a larger cone and a smaller cone. Now we have seen that the surface area is given by pi r squared plus pi e to pi L or to pi r L. Now our intention and our objective is to get the surface area of the frustum. What do we need to do? First, get the surface area of the larger cone. Get the surface area of the larger cone. Get the surface area of the larger cone, which is now area is equal to 2 pi r L. And now what is our L? Is x plus this slant height of the frustum. This one will help us to get the surface area of the larger cone, to mean the initial cone before the frustum was made from it. Then the next thing that we need to get is the surface area of this small cone. Of a smaller cone. The cone of the upper part. What is its slant height? The slant height of that cone, the slant height of that cone is this x here you are seeing now. Is this distance from the smaller circle toward the point of where the two slant heights are meeting. That is the slant height of that cone. How do we get the surface area of that small cone again? The surface area of that cone again is given by pi r squared plus 2 pi r L. Now, what is this our L? Our L now is h. Where does L? You substitute by the h. Now, to mean area of small cone, AS, is given by pi r squared plus 2 pi r h. And I've said this x here means the slant height of the smaller cone. Are we together? Are we together? You can type yes in a comment if you are together, if you are understanding. Then, I've told you earlier on that our intention and our objective is to get the surface area of a frustum. We need to come up with this frustum. Now, we have the surface area of the larger cone, to mean the whole cone, and we have the surface area of the smaller cone. Now, what do we need to do to get the surface area of a frustum? What do we need to do to get the surface area of a frustum? Take the area of a larger cone, subtract the area of a smaller cone. Take the area of a larger cone. You see here I have got AL. AL to mean area of a larger cone. AS, area of a smaller cone. To get area of a frustum, AF is given by area of a larger cone, AL minus area of a smaller cone, AS. Area of a larger cone minus area of a smaller cone. To make larger cone is the whole cone. Area of a smaller cone is the area of the cone at the top here. If we do that, we shall have come up with the area of this frustum. We shall have come with the area of a frustum. Now, we want to have an example so that we see if we can calculate the surface area of a frustum. Now, our example is here. A frustum is made of a cone with a radius of 7 and 14. A frustum is made of a cone is made of a cone of radius of 7 centimeters and 14 centimeters and 14 centimeters. The height of this frustum, the height of the frustum, the height of the 12 centimeters. Roman 1. Calculate the slant height of the frustum. Calculate. Roman 1 is calculate the slant. Welcome back again. Now we can proceed with our equation. We see how can we solve the equation to calculate the area of our slant height and the curved surface area of a frustum. Now, here we have a frustum as said. The first thing, we form a conical and we form a cone by extending our slant height, so that we have a cone here. Now, as you extend the slant height, extend this height again, the perpendicular height that cuts the frustum into two halves. Extend this slant height again, so that you see what you have. We have the height of a frustum is 12. But what about the height of the whole cone? The height of the whole cone here now, learners. The height of the whole cone now starts from where you are seeing 14 is here, 14 centimeters. At this base here, up to the point where the two slant height are meeting. That's the height of a cone. The height of a cone starts from where you see from the base where 14 is up to a point where the two slant heights are meeting. Then, but at the top here of frustum we have from 14 up to the top of frustum we have 12. Now, the part that we don't have and we don't know is the only part from where 7 is up to the point where the two slant heights are meeting. At that particular point, use any letter of your own choice to represent that height. Use any letter of your own choice to represent that height. And you, last, I know that you are well familiar with the letter X. Now assume that this point here is our X. That X can represent that just a value that we don't know its magnitude, its weight, we don't know. So we represent it by a letter. So the total height of the whole cone starts from where 14 is and where the 2 points are meeting, up to where the two slant heights are meeting. Slant height B. Okay? This is the slant height. But height we have this. Now our total height, capital H, that part at the top, from 7 to where the 2 points are meeting, which is x plus x, that becomes our height, the total height of that frustum. And there's something that we have here. We have got 2 radiuses. One bigger radius and a smaller radius. There is something that you learned when you are doing something on enlargement of objects. Under transformation, enlargement and rotation and reflection. You learned about something on linear scale factor. Linear scale factor. This again, that knowledge, the same knowledge that we used there in enlargement can be applied here when we want to calculate the height of the whole corner. Why am I introducing this concept? Because it is the base that was, it is either the top which was enlarged to give us the base, or the base here was magnified to give us what? To give us the top. Okay? So, to mean one of the objects here was a line. So what do we need to do? We need to come up with linear scale factor to get the total height of the whole cone here. Okay? Now, how do we use a linear scale factor? We are saying that the ratio between larger radius over smaller radius is equivalent to the ratio between the total height of the cone, which is now 12 plus x over the height of the smaller cone. And what is this height of the smaller cone here? The smaller cone here starts from this point, this particular point where I see my pen is, up to the upper part. This is the smaller cone. The part which was cut to come up with the frustum. What is its total height? The total height is x. Now the ratio between larger radius over smaller radius should be the same ratio between larger height over smaller height. Our smaller height is x. Now what is our larger radius? Our larger radius is 14 over smaller radius, which is smaller radius, that small sample, which is 7, is equal to 12 plus x over x here now. Now learners, what do we need to do here? We need to find the value of x. And getting the value of x, what do you do? Cross multiply. If you cross multiply, we say that you have 14x is equal to 7 by 12, you get 84. 84 plus 7x. Now, as usual, we say that we cannot put Otieno and Anyango together. We collect the like terms. What I mean here, collect the like terms. 14x. Take this 7 the other side, it will be minus 7x is equal to 84. What is the value of x learners? You can type in the comment. Our x here now becomes 7x is equal to 84. Divide by 7, divide by 7. So that our x to be 12. Now the height of a slant height is 12. This height is 12. What about the total height of the whole cone? We have said the total height of the whole cone, capital H here, is 12 plus x. What is x learners? In a comment, x is 12. Now, what is x plus 12? It's like you're having 12 plus 12. In a comment, give us answer, which is 24 centimeters. That's the total height of the whole cone now we have. Of the whole cone. So, our solution was to you are supposed to get the slant height of a frustum. But that's the just height of the whole cone. What do we need to do now? What do we need to do now? If you check very well, this one here is a 90 degrees. To me, it's a right angle triangle. It's a right angle triangle. It's a right angle triangle. From here to here, from this base up to this particular point is 24. But from here to here is 14. What is this height? What is this height? Which method do we use? Pythagoras theorem. Which is this one to be our A, B, C. We don't know that Pythagoras theorem C squared is equal to A squared plus B squared. To make it what C, which is now our slant height of the whole cone, again here find the square root. To get this one here, we need to have 24 squared plus 14 squared, then we get the square root. What are we getting? What are we getting? 24 squared plus 14 squared, we get the square root. Minus. You see again at the top here. Here we have 12. And we have 7. Minus again 12 squared minus 7 squared. This one will help us to get the slant height of the frustum. Now if you do this, what are you getting? If you do the 2, what are you getting? And ask in our comment, you can type, if you do the 2, what are you getting? 24 squared plus 14 squared, you get the square root. Minus 12 squared minus in bracket 12 squared plus 7 squared. Again, you get the square root. You get the difference between the two, gives us what? The slant height of this particular frustum. If you do that, you are going to get the slant height of that frustum. Up to that point, I think now we are okay. You can check your answers of the slant height in a comment or frustum, then we see what do we have. What do we have, so that we proceed. So that we proceed with the curved surface area of a frustum now. Curved surface area of a frustum. Now as you type your answers on the slant height, I want to continue with how do we get the surface area, curved surface area of a frustum. The first thing I would say, we get the area of the whole cone. We get the area of the whole cone plus, then we subtract the area of a smaller cone. We subtract the area of a smaller cone. Now, the term here is curved surface. Curved surface. Curved surface. Not total. Not total surface area. The term here is curved surface. To me, curved surface area is only this part. We don't include the base and the top. We don't include the base and the top. Now, yesterday in our lesson, how are we getting the area of a curved surface? Area of a curved surface was by dl or 2 pi r l. 2 pi r L. 2 pi r L. Now here, to find the curved surface area of the upper part and the curved surface area of the whole cone. Curved surface area of our whole cone is this one. Pi, 2 pi, and use capital L. Your L, it is the slant height of the larger cone. The slant height of the larger cone. And how do you get slant height of the larger cone? 24 squared plus 14 squared. Then you get the square root. Then you get the square root. 24 squared plus 14 squared. Then you get the square root. This one is the same as saying that we have 2 times 22 over 7. What is our R? For the bigger cone, our R is 14 times 14 times the answer here. There's an answer here. 14 squared meter. 14 squared plus 24 squared square root. The answer there. The answer there. In a comment you can type. 24 squared. 20. That is 24 squared. 24 squared plus 14 squared. Then you get the square root. 27.78. It is 27.78. You do that, then you get again, you use 2 pi r L. Now, why are we using small r? The curved surface area of the smaller cone, the cone of the upper part, which is 22 times 7 times what is now the slant idea? The slant idea 12 squared plus 7 squared, then you get square root. The slant idea 12 squared plus 7 squared, then you get square root. Okay, runners, you can also get the slant height 12 squared plus 7 squared, then you get the square root. 13.89. It's 13.89. Now, class, we have to calculate the curved surface area here, calculate the curved surface area here. That will be the answer. What are you getting? In the first one, what is the answer? In a comment. Then the second one, what is the answer? In a comment. What is the answer in a comment? 27? 27.8. 13.9. Yeah, another one is 13.9. Okay. But you must know that this one is centimeter square units. Centimeter square units. Now we need to get the area of a frustrum. Now, assuming that
Susan Akeo, you appreciate the name. Susan Akeo, Napata Kwanza, Diana.
Okay, Susan Akeo, thank you for the first one. Diana, thank you for the second one here. Now, we need to get this curved surface of our frustrum. Assuming that this part is not there, you part in the foot hapo is not there, that part is not there, and that part was having 13.9. What part is being left now? What is being left here is the frustrum. Now what do we do? Take the part which has been cut, subtract from the original cone. What are you getting? 27.8 minus 13.9. What is the answer? Learners, what is the answer? What What is the answer? What is the answer? That one is how many people are getting 8.9? In a comment, 8.9? In a comment? 8.9. Oops.
That is called
Munga. Okay, Munga. Thank you for your answer. The answer here is 13.9 centimeter square. Thank you for that your answer. Now that's how we calculate the surface area of a frustrum. The first thing that you need to do in summary, you first extend to form a cone, then you get the area of the larger cone and the area of the smaller cone, then you subtract the two. Now assuming that let's say our cone was a solid, assuming that the cone was a solid, to me, if the cone is a solid, we need to add this upper part, the bottom part, and the upper part. Assuming that the cone, if the cone is a solid, to me, the upper part, the top part is curved, the bottom is also curved. So what do we do to this? Our curved surface. We add this part, and how do we calculate the area of the upper part? Is pi r squared. The bottom part again is pi r squared. But you can see the difference between the r. The bottom is capital R. The upper is small r. Then if you add these two areas, add to the curved surface. If and only if our frustum is in a solid form. In a solid form, I'm saying every part is covered. We have got the curved surface, this part. We have got the upper part. You get its area. We have got the bottom. We have got the bottom part. You get this area. You add everything here. You get the surface area. But assuming our frustum is in a form of a plane like this, in a plane like this part goes here. What do you need to do? Take the curved surface and the part which is there. Only one part which is there and. Okay? Let us, if it is open at the bottom, add the upper part alone. If it is open at the top, add the base alone, plus the curved surface. Thank you. I will now let in another presenter to take you through the frustum of pyramid. Thank you for listening. Thank you for your time. So,
yeah. What's another?
Welcome. That was session 1. We are happy that you people are watching from home and following up the charts. However, under the comment section, there are some who are busy sending regards to one another, and that denies the time to concentrate. We are asking the learners to take time and concentrate on the concepts that are being passed at the expense of greeting one another. Thank you for listening and following. We keep you abreast with the development. Thank you very much.
Okay. Good morning once again. Welcome to our next session. That is, we want to look at how to work out on some surface areas of a pyramid. We want to look at now the surface area of a pyramid. Surface area of a pyramid. And when we are talking about surface area of a pyramid, that is still under solid. So we have two types of pyramids. Number one, we have a square-based pyramid. We have a pyramid square-based. Then number two, we have a rectangular based pyramid. So we are going to work on them one. I'll use an example in each case to help you understand this particular pyramid. So I will begin with a square-based pyramid. So let us look at a square-based pyramid. So in this case, you can be given a question like, first let me draw that figure. Let me draw it here. Let me have my diagram here. Here. This is a square. And then we're given something like this. Given something like this. So that is a diagram that is used to represent a square-based pyramid. This side, this base is a square. So when the base is a square, this is what now we call a square-based pyramid. Meaning it is a pyramid with a square base. And when we are working out this diagram, a figure like this and not only the surface area, we will have to get the area of one individual face. And because all the faces in this pyramid are equal, that means we only find a way to work out one face. Once we work out one face, then we shall have to multiply by 4. So we work out the area of one face, which is a triangle. So once we work out the area of one triangular face, we multiply it by 4. Then after getting the answer, we add the area of the base, which is a square. So our main task here is to work out the area of one triangular face, then multiply by 4, then add the area of the square base. I hope now I'm clear. Now, a good example here. The figure below let me use a pyramid, a solid pyramid with a square base of side 32 centimeter, given that the height, the perpendicular height pyramid is 30 centimeter. Calculate the total surface area of the pyramid. Now, given such a question, you are told the figure below, which I'll draw here, is a pyramid with a square base of side 32 centimeters by 32 centimeters. Of course, a square has all sides equal, so it is 32 centimeters by 32 centimeters. Then the height that we are given is the perpendicular height, which comes from the top to the center of the square base, where the diagonals of the base meet. That means that height, if we call this point where the diagonals intersect, we call it O, then, and this is A, B, C, D, and this is E. Perpendicular height that is given as 30 is this one here. In other words, we can represent it like this. We can represent it like this, up to where the base is as 30 centimeters. So OE, that is, O is the center of the base where the diagonals meet, up to E, which is the vertex up there. So that is the vertical height. Now, it's given as 30, and the sides are given as 32 each. Now, I want us to see, how do we go about working out the area of one individual triangular face, which we shall now multiply by 4, then add the area of the base. Hi. I want us to extract one triangle from the diagram. If we come, let me pick ABE. Let me pick a one slanting side like A, B, and this is E. If you check this thing well, the vertical height that is given, it is of the mean diagram. It means the slant height length is not given. I hope we are together, learners. The slant length of these sides is not given. We are only given the vertical height of the diagram, of the solid, which is a 3D. So we have first to come and get either the slant height of this side, or we get the height of each face. Now, with this face given, the base is 32. We need this height here of this face. This is the height of the face, not the vertical height that is given in the diagram. Let me have the diagram that illustrates those things. Let me show you the difference between the two heights I'm talking about. Assuming this is now one face. Let me have this is now my face, A, B, and E as my face. I think you can see it now very clear. Having A, B, and E. The height that I'm looking for is this one. The height I'm talking about now will be this height here of this my face, which I'm saying we have to obtain it from the vertical height of the diagram. And if we want to get the height of, let me say this face, ABE, so it will be this vertical height, and then from O to this line AE. So we shall have something like this. We shall have this E to O which is the center, and again we shall have O to maybe to this side. If it is AB, it will be O to AB. That means we shall find we have the distance O to where this point is cutting the AB.
Use this.
I use this side.
Move.
It's okay.
And
So I want you to get me clear. This diagram, I want to obtain, let me say, this height of one side. So I will use the perpendicular height of the diagram to O. Then I will join a line from the center to the midpoint of one of the side. For example, AB. So we shall have it there. Let me call that point M. So M is the midpoint of AB, which is the face that I want here. Now M is here. So
Draw that one this side.
let me draw again that my side. So I say this is A, B, E. So I have this perpendicular height of this side, and this is M, where M is the midpoint of this side AB, this triangle. So I'm finding a way we want to get this EM. After getting EM, we shall work out the area of that face straightforward. So once we have this vertical height, which is 30, then I will join this line from the center to where the line is meeting AB at M. So this side, we know that the whole length is 32. And because OM is a half of CB, it's a half, it is now 16. I'm saying, because we have divided this, O is the midpoint of either the diagonals or the sides. That means OM is a half CB or DA, as the diagram is showing. So we shall say OM is 16. So we have E now to O, then O to M. And our main M is EM, which is here. That is now what we are looking for. But remember, EO is given as 30 centimeters. And OM is a half of this side, which is now 16 centimeters. And at that point, once you are able to identify where the vertical height will help you, and this half, which is OM, a half of this side, then you are able to get this by Pythagoras theorem, where this perpendicular height meets the base at 90 degrees. We know that because it is a perpendicular height. It is perpendicular to the base. Therefore, this is the hypotenuse. By Pythagoras, we say hypotenuse squared is the base square, which is OM, plus the height square, which is OE. That will give us hypotenuse squared as base that we have seen as OM is now 16 U square plus our height, which is the perpendicular height given, is 30 U square. That will give us the hypotenuse square as, let us work it out and see, the 16 square, that is 16 square, that is 256 plus 900, that will give us that hypotenuse square will give us 1156. Now, that is the square of a hypotenuse. To get the hypotenuse itself, now, as we know, we find the square root of 1156, which will give us exactly 34 centimeters. Now, we have this face here, which has A, B, and E, and it has a height of 34 of this side. It is now 34, which is EM. Now, if this is 34, if this height here is 34 and the base is 32, I know now you can tell how we get the area of that face. This face is a triangle with the base given, the height has been obtained, so we shall say area is equals to a half base times height, where area it will be a half times. We use the whole base. The whole base was AB. The whole base AB, which is 32. 32 times the height. The height is the ME that we have worked out, which is now 34. When you work out that thing, it will give you 544. 544 centimeters square. I'm a square centimeter. Now, learners, whatever we have obtained is the area of this one side. And as I said earlier, this is a square-based pyramid, and all the faces are equal. So once we obtain one face, we only multiply by 4. We shall have obtained all the 4 faces. Thereafter, we now add the base, which is a square. Alright. So we shall now say total. Then we find the base. The base will be side times side, which is now, because it is a square, one side of the square is 32 times 32, giving you 32 times 32, giving you 1024. 1024 centimeter square. So that is the base. We have the base, and we have one side of the triangle. So what do? From the comment, we multiply the triangle times 4 plus the base. So total surface area will be base area plus 4 into the triangular face. So the base area, we have it as 1024, plus 4 into the triangular face, the area, we have it as 544. That will give you, if you work it out, it will be 4 times 544 plus 1024. That gives you the total area as 3,200 square centimeters. And by doing so, we shall have obtained the total surface area of a square-based pyramid. So just understand that part of getting the height of this particular face. We've said we use the perpendicular height as the height, and then when we extend this line either towards this side or towards whichever side, it will be a half of these sides. Then by Pythagoras, you get this height of our face, which will act as the hypotenuse of whatever we have said.
Give them one, then you wait for your 2 layers.
Alright. So Maybe I want to give you one as just a small one, then you work it out and drop for me the answers in the comments. I'll be marking from the comments. So I want you to get me the total surface area of the pyramid that I'm giving you here. Of the pyramid that is given here. The pyramid. This is a square-based pyramid of side then the vertical height is 8 centimeters. 8 centimeters, yes. So you can work it out and drop the answers in the comment section. Calculate the total surface area of the solid pyramid below.
The lesson is interesting. Slowly, please.
So hurry up, guys. I'm waiting for your answers in the comment section. Why do I use it? It was given. Yes, it was given.
Just respond.
So,
from the comment section.
I'm seeing from the comment section somebody is asking why I used 30. 30 was given in the question the same way I've given you 8 as the vertical height about the perpendicular height of the figure of the pyramid. Christina, ask your question. Christina, ask your question. Christina, I'm waiting for your question.
But they are really good. Yes, sir. The photo that you give no one.
You wanasema tumia roads formula 8 after use land. I'm waiting for your answers. I'm seeing Lillian giving us the answer as 836. No? Lillian, check you're working well.
32 million kwanza.
There's 544. Somebody here, someone.
We're getting to 4. No, the answer is not 384. 384? No, yeah, 384 is the answer. 384.
Just give them time.
So-
What's the correct one? What's the correct one? What's the correct one?
Okay, let the answers keep coming. Let the answers keep coming.
384. 836 kasoma gani?
So wewe wakishaweka wengi utawaambia sasa the correct one alafu unafanya na final list.
384.
Let the answers keep coming. I'm seeing some having 192, some having 336, some having 384. Let us keep trying. Majority are getting it now.
Not the 336, but 368, 64.
Do I not proceed? Do I proceed?
Yes.
Proceed and give them the answer.
Okay, thank you. Let us now work it together, then we shall see whatever the answer was. Now, pay close attention to whoever feels has not understood me well as I'm working through this. So, we have been given the height, the vertical height as 8. So, let me label this diagram. Let me give it A, B, C, and D as my base. Then, this one can be X, the vertex. So, I want first to establish where my 8 centimeter is. That means, at the center of the base, where the diagonals intersect, let me call it O. So, that O, when joined to the vertex X, that is where we always have 8 centimeter the perpendicular height. It means it is X to the center of the base, where the diagonals meet. That is 8. But I want my height for this face ABX, this height. So as we say, we shall use this 8 and half this base. For example, we can join to this here, to the middle point between A and B. We call this point even N. So ON is a half CB, as we know. That means ON is 6 centimeters. So if ON is 6 centimeters and OX is 8 centimeters, then XN becomes the hypotenuse because XO is a perpendicular height to the base. That means OX, the perpendicular, the right angle is at O. So if the right angle is at O, XN becomes the hypotenuse, as we did. Therefore, we shall have something that looks like this. We shall have X. Now this is O, then we shall have our N. So ON is a half of 12, which is 6 centimeters, and the height is 8 centimeters. So we need our hypotenuse, which will now act as our height in this face. It is our hypotenuse here, but when we come to this face, it will be our height, perpendicular height for that particular face. So, let's get it now by Pythagoras theorem, which says hypotenuse will be the square root of the base square plus the height square. Therefore, our hypotenuse will be the base square is 6 square plus 8 square, giving us, this is 36 plus, when 8 is squared, it gives us 64. So when you add 36 plus 64 is 100. Therefore, our hypotenuse there will give us 10. So our NX is 10. And now, that is now our height here. So when you have this height, and you have the base as 12, Therefore, the area is a half times 12 times our height, which is 10. So, you want to get the area of now that face. Let me extract it for you here. So, let me pick this face here. This is the face X, A, B, with a perpendicular height 10 centimeters now, and the base 12 centimeters. So the area of that face will be a half times base times height, which will give us a half. The base is given as 12 times the height is 10. This will give you 6 times this 60 centimeter square. That is one triangle. The base is a square, so we say the base is side times side, where each side is 12, so it will be 12 times 12. The answer from the comment section is 144. So it is 144 square centimeter. And I say to get the total surface area, because all the triangles are equal, we shall multiply the area of each triangle by 4, then add the area of the base. I think I said that. So, we have the area of the triangle, we have the area of the base. So, total surface area will be the base plus 4 into 60. So that will give us 144 plus 60 times 4 is 240. So when you add 240 plus 144, it gives us 384 square centimeters. So those of us who gave us 384, I think you are right. And those who did not get that, I think you've now seen where the mistake was. Now, I want us now to look at the frustrum of the same figure.
So we can also look for the frustrum of the same figure. Then you can also tell them, apart from using that method, we can use Hill's formula. So just highlight, but if the slant
now, I saw someone say that, can we use the hero's formula? Yes, it can apply when getting the area of this one side. And if we are to use the hero's formula, now we shall use our this height and a half the diagonal of the base. That means you will have 12 and 12. This is a 90 degrees. Use Pythagoras theorem to get the diagonal of the base. Then if they assume the diagonal, you get something like, let me say 15, then a half of it, that is AO, will be 7.5. You use that against 8 to get this slant height, which will be now hypotenuse. After getting it, all these slant lengths are the same. So when you have it, and it will be the same for this one, and you have the base. You will use Hero's formula, you get the area of that triangle. Then multiply it by 4 and follow the same thing that we have done. Right? So, I want us now to talk on a frustrum of the same pyramid now. And a frustrum is now the solid form. When I come and cut, let me say I cut this solid like this. I move and I eliminate the upper part. For example, if I come, let me show you something here. Let me just illustrate it afresh so that we can go together. Assuming originally we have something like this. This is now the pyramid that we just talked about. Now, when I come and now eliminate, let me assume I do this. And now eliminate this other part completely. Now, such figure. I have chopped off the top part of it, and the figure that I've just removed is another small pyramid. So it means a frustrum of this pyramid is formed when you cut off a small pyramid from an original bigger pyramid. So whatever is left behind is now what we call the frustrum. I hope I'm now clear. So we have chopped off, or we have cut off a smaller frustrum, a smaller pyramid, to leave behind are now what we call a frustrum. And remember, this is a frustrum formed from a square-based pyramids. For example, now assuming if this is a square, then the top is also a square. In this one, the total surface area shall be the area of these faces. That means one face times 4 plus the bottom, which is a square, plus the top, which is also a square. So we are adding top, bottom, and the 4 faces. From the comment section, who can tell me the shape of this one face, of this frustrum? The shape. For example, A, B, C, D, E, F, G, H. A, B, C, D is a square base. But what about A, B, E, H? Who can tell me the shape in the comment section? The shape of A, B, E, H. Yes, this face. I'm waiting for your answers in the comment section. Anybody? Those who are with me? Aye. This shape is a frustrum. This shape is a frustrum. Now, we all know how to get the area of a frustrum, but I'll show you how. Trapezium, yes. Yes. I can see somebody has already told us it's a James that is a trapezium. Hi. Now,
Someone is saying a triangle when extended.
yeah, when extended is a triangle, but now we don't want to extend it. Someone is telling us it's a quadrilateral. Yes, it is a because it's a 4-sided figure, but now it is a trapezium. Let us move on. Now,
what is the meaning of frustrum? Question.
Someone is asking the meaning of a frustrum.
As I explained it, that a frustrum, it is now the solid that is left behind when you cut off a small pyramid from an original bigger pyramid. That means you cut off the top small part of a pyramid, whatever is left from the remaining part of the pyramid is now the frustrum. Yes. Now, let us have an example here. Let me retain this image. The figure below shows a stool, a stool in the shape of a frustrum if the top and base with the top and the base square. Okay, frustrum with a top and base with a square top and the slant length of the frustrum is 9 centimeters. Calculate the total surface area of the solid. That is the question. The figure below shows a stool in the shape of a frustrum with a square top and base of side 8 centimeters by 12 centimeters respectively. That means this is 8 by 8, this one is 12 by 12. And when they tell you the slant length is 9, they mean this here is 9 centimeters. That is now the skeletal figure of what we have. I hope you can see the diagram. I hope you can see the diagram. Now, this is the diagram. It has a top square of 8 by 8, and a bottom square of 12 by 12, and a slant length of 9. So you want to see how do we get the area of one face, which we shall multiply by 4, then add the top and bottom, which are both squares. So our main activity here is first to obtain the area of this trapezium, as you have told me. Let me extract it and bring it here so that we can work on it separately. Let me pick this face here. This is a face H, E, A, B, which is given as 12 centimeters. On the top, 8 centimeters, 9 centimeters. Remember, all these sides are equal. 9 centimeters. When we want to get the area of a trapezium, we use the formula area is equal area of trapezium is equals to a half into a plus b times height. In this trapezium, this small side, the upper small side is my A, and the lower bigger side is my B. Whatever I want is now the height. So I will drop these two heights, perpendicular heights here and here. This is the H. And you can bear me witness that if this is 12, this is 8, and this side is equal to this side, that means this small part here is the same as this small part here. I mean, we know this is 8, so this one is 8. From here to here is 8. That middle part is 8 centimeters. Out of the 12, we remain with the 4. This 4, we divide it equally and give this side 2 and this side 2, because because this side is equal to this, therefore this is also equal. Now, having that, I can now extract a small portion of the triangle. I will extract a small portion of the triangle. This is my H. I have 9 and I have 2. And because this is a perpendicular height, it will form 90 degrees there. So I want to get to my height. How do I get to my height? By Pythagoras theorem. Okay? So I will say height is equals to the square root of Pythagoras theorem. When we want to get the height, it shall be the hypotenuse square minus base square. So hypotenuse square minus base square. So our h will be the square root of, our hypotenuse there is 9. So it is 9 square minus our base is now 2. So you square 2. Our height becomes the square root of 9 square minus 2 square will give you 77, which now our height will be the square root of 77, that is 8.775 centimeters. So up to that point, we now have the height. That here is now 8.775. So you can now get the area of the trapezium. I want to move to this other side. So we will come and say the area was a half into our A. We said our A is 8. As indicated, it is 8 plus our B, we said is the whole lower side, which is given as 12, as I've indicated, 12 times the height, which we have now worked it out here as 8.775. That will give us a half times 8 plus 12 is 20. So times 20 times the 8.775. So if you work this out, it is going to give us 87.75 square centimeter. That is one trapezium. That is for one trapezium. That is for one trapezium. But from our solid, we have 4 trapeziums, trapezia. So let us work out the bottom, the base. Then we have the area of the top. Then we add them and we multiply this by 4, then add. So let us have the base and the top. So area of top will be side times side, which will give us 8 times 8, that is 64 centimeters square. That one goes there, we will have it like that. We go to the bottom, it will be side times side, that is 12 times 12, that is 144 square centimeters. Now the total surface area will be top plus base plus 4 into one trapezium. So we shall multiply the trapezium that we obtained by 4, then we add the top and the base. So that the top will be 64 plus 144 plus 4 into 87.75. So when you work out all the values, they'll give you they'll give you 559 square centimeters. And by doing so, that is our total surface area of that frustrum of a square-based pyramid. Is there any question before I give you one to do? Maybe there is a question before I give you one to do. Maybe there is a question before I give you one to do. Yes. Now, I want you to try this, then I'll mark. You do. We just test if we are well to go. Let me use 14. Let me use 14. And then we can have here a 7 centimeter. That is excellent. So you can work out, calculate the total surface area of the frustrum. So you can work that out and drop your answer in the comment section. Now, I've seen a question, even the rest you can keep working on it. I've seen a question that when you are told to work out the frustrum, but you are given a half. A half, that means that is when maybe you will be told the height is halfway. When it is the vertical height that is half, it means the linear scale factor is a half. Maybe if you are given, maybe it was cut half, the vertical height. So it means it would have been, let me say 10, so they cut it 5. So the linear scale factor will be that half. That means the linear scale factor will be, you will square that half to be a quarter. Therefore, the part given, you multiply its area by 4 to get the area of the original big frustrum that would have been cut into half. Unless you mean a half of a cone, a half of a pyramid, I don't know. So I'm seeing people giving out answers.
summarize and close this. So when we start the next lesson, we review that answer.
I will do that. So we can close it there, then when we come to our next lesson, we shall review on the answers. Thank you very much. Have a wonderful day. Thank you for your cooperation.
Thank you.
May present is everyone.